Okay, so at the beginning of class, I was asking people if they had a particular problem, like in their homework, that they had trouble with, bring it to class and I can actually do it. So, yeah, somebody has a chat. A minus a third, subtract. What are you supposed to do with that?
I like in the video when he was teaching us how to like subtract with the algebraic expression. So I wanted to try one of those. It
Okay,
was like he gave us subtract a minus one third, and then the other problem was add 8 plus 3x.
okay. So, yeah, all righty. Well, here's a couple of problems we can work on. So I'm going to go over to this and see what we can do at this point. Okay. So I definitely know this first one about the lines was getting people in trouble. Um, you probably remember that. So I think who I just talked to, probably turn off your mic. There. Okay. Okay. So the problems, most of them looked something like this. And so here, what happened was each one was slightly different, and some of them were worse than others. But for instance, if they had marked it off into 4 pieces, so every from 0 to 1 was 1, 2, 3, 4, and you were lucky enough to get a problem that said in fourths. So the number line is divided into 4 equal parts from each number, from 0 to 1 or from 1 to 2. And you were lucky enough to be asked to do 3/4, then all you had to do is, this is 1/4, 2/4, 3/4. And so all they wanted was the solid dot, not a number line, because I know that was one of your choices, not an open circle, but a solid dot, just like that. Okay. Now, sometimes, and I'm just going to go from 0 to 1, just so I don't have so many things to mark. Sometimes, instead of having 4 marks across from 0 to 1, they had 8. Okay, so you'd count them 1, 2, 3, 4, 5, 6, 7, 8. And again, if you were lucky enough, the question they asked you was in eighths. So for instance, if they said, oh, let's say 5/8, and it was marked in eighths, life is good, and all you have to do is count 1, 2, 3, 4, 5, and you'd put a mark right there. The problem that made these difficult is, what if they didn't give you that? What if they said 3/4? Now it's 3/4, but this line is marked in eighths. So what you have to do is convert this into 8. And then you can just plain old count over. So this is expanding this to make it higher. And so to make a 4 into an 8, that's not such a bad deal. All you have to do is multiply by 2. So 4 times 2 is 8. But once you multiply this number by 2, you've got to multiply this number by 2. So it stays equal. And 3 times 2 is 6. So even though they told us they wanted you to mark off 3/4, in order to get the right spot, you've got to turn it into eighths so it matches up with the lines. So we're talking 1, 2, 3, 4. This was the center here. 5, 6. And so you'd have to put your mark here. So that was the very first thing you had to do, was to see how many marks on your number line, and then what's, the bottom number of the fraction they're asking you to do. And if it doesn't match up, then you have to convert it so that it matches up with that. Now, that's not the worst of it, but that's the beginning. Any question about that? So you get it into 8. So this one was in 8s because it was 8 marks. If you were really unlucky, well, I don't know about unlucky. I get somebody to help me with this. Okay, so what if it was marked in 8s? So so this is the center. So you count over 1, 2, 3, 4, 5, 6, 7, 8. So it's in 8s. But what if they ask you to locate 3 over 16? This is having to go the other way. And so we only have 8 marks, and we literally need to think of it as 3 16 marks, 16. And so what you're imagining is a little mark in the middle of each. Now, you can't put those marks in because this was defined. It was already in 8s. But when they want 16, you have to imagine 16 marks. Once you do that, and maybe you could put this on paper so that you definitely got it. This would be 1 16th. This would be 2 16ths. This would be 3 16ths. And so you had absolutely no choice but to put your mark halfway between this one and that one. That is 3 marks, 1, 2, 3, when you marked it in 16ths. I worked with somebody and they didn't like this problem one little bit. And I said, ask for a similar problem. That's what you do sometimes when things get frustrating. But I wanted you to see that this was the worst of them, when they asked you to divide it into 16ths and you didn't have that many marks. And so you had to kind of pretend there was a mark in the middle there, making it 16 total marks. Now, I can work with people individually on their particular problem, but I wanted to show you that because I do know that is a bit of a problem. This one here, I think we've already seen this, and so I can do the ones that we've already seen. It was a word problem, and it said the family had this kind of income, 2,070 was their total income, and the house payment was 1,650. So this was the house payment or the mortgage. And what they wanted to know was what was the fraction for the house payment. Okay. So to get the fraction of the house payment, what you literally do is have to put 2 numbers in. First one is the house is the top of the fraction, and the total income is the bottom. And total almost always belongs on the bottom. And so what you need to do is the house payment was 1,650 and the total income was 2,070. Okay. Now, I think if you type this number in, they would say, couldn't you make this simpler? You know what I mean? In other words, instead of a number like 10 over 20, you would enter 1 over 2. You know what I mean? And the fact that it has zeros at the end makes our life a little bit simpler. So that, and I have no idea where this problem came from, but this, the 2 zeros at the very end can be reduced. It's like dividing by 10. And so I think this answer probably would have been accepted. So you would pull off the 2 back zeros, and then you have 165 divided by 207. So you enter it with this, because I don't think there's a division symbol. So you just use that from your computer or your screen there. Okay.
I looked at the key because I was confused about those questions as well. So I looked at, I bought the actual book and I looked at the back of the key.
Yeah.
And I found that the similar problems that they had listed, the answers, they just put 1650 over 2070.
Oh, so
and
they
that-
didn't even expect you to reduce it.
Yeah, and I was kind of puzzled. I was like, okay, so I guess it's more so just
It's really
reading.
So really, it's this.
Right, exactly. Finding what's the denominator and the numerator.
Exactly. The
Right,
total
yeah.
goes on the bottom.
Okay, yeah, I just wanted to clarify.
Yeah. And honestly, I mean, I bet if you did that, if you entered that, it would have accepted it. This is a very, very good trick to take out trailing zeros is what I'd call it.
Okay, perfect.
That's, yeah, so if they took the other way, life is good. Okay.
Thanks.
And let's see, I think what somebody's asking for, I'm going to do mixed numbers fairly soon. But I wanted to do the 2 word problems. So this was what somebody asked. So if they said subtract a and the 1/3, the thing they want you to do is right here, subtract. And so this is a standard problem where the order, the first is first, the second is second. And so it's a subtract 1/3. And that's all I wanted you to do. Take it out of English and turn it into math. That's all I wanted. The second one was if they said add, and then whatever they say, what 2 things they ever say, 8 and 3 times x. Clearly, they want you to add these 2 things. And so it's 8 plus, and then this 3 times x, times is multiply. And so that would be 3 like that. But what we've talked about is they like things as simple as humanly possible. And so 3 times x, we'll just end up saying 3x. How's that? So this problem, that's all they wanted. Getting to the point where you can take the words and turn it into math. Be done with the words, goodbye, and turn it into the math properly. And what they say, the very first thing they say is the critical thing. It's an addition problem. It's that one plus that one, okay? So what I wanted to do, I know I haven't done every little bit about what people asked about, but I want to get started with 2.3. And I think we'll pick up some of these things as we go. See if I can bring this down. The very first thing, I've been kind of hinting at this already. When we look at a number, like the number 15, I'm seeing more than just the number 15. I'm seeing what it's made of. And what it's made up are the two numbers that multiply to make it up. So this, the 3 and the 5 are factors. Okay? And the 15 is the answer, and we already said the word, it's product. Okay? Now, how is this going to help us? Well, it's going to help us in a lot of ways. And so the trick we're going to have to learn is, how do we see the factors? Or how do we recognize a number that doesn't break down any further? 15 broke down into 3 times 5. Some numbers you can multiply by 1, but that's about it. And so what this is going for is prime numbers. And if you've had it before, this is good. If not, let's talk about it. Prime number would be a number like 5. The only way to get it, if you multiply, is to go 5 times 1. You can't break it down any further. Or you could say the only thing that would divide it would be a 5 or a 1. I usually tend to go with this definition, but it doesn't break any further. So we're almost down to the true essence of the number. There's no more breaking down. And so the question is, what's the first prime? Well, every number multiplies by 1, so they exclude 1 in the list. But the first number that makes the list is 2. Because the only way to get 2 with multiplication is 2 times 1, using whole numbers. The next number is 3. 3 times 1, that's it. But the number 4 is in a different category. Although 4 is 4 times 1, which, like every number is that's true, it also can be gotten multiplying 2 by 2. So 4 is not a prime number. It's called composite, and the words probably don't matter unless you make a list of words, just so that you don't get twisted with words. But composite numbers are not prime. They have other factors other than the number itself and 1, something else. And so 4 is not prime, but 5 is. Because 5 times 1, that's the only way to get it through multiplication. Now you're probably starting to see that the even numbers, the numbers like 6, have to fit into this category of composite, because you can get that by this, 2 times 3. So the even numbers at this point are totally out. So 6 is out. And so we really just need to go to the odd numbers. And what are even numbers? Well, even numbers are 2, 4, 6, 8, and anything ending with a 0. Those are the evens. So the only one that makes the list is 2. After that, there's no more even numbers. So I'm going to go to 7, and I'll think about it. 7 times 1, 7, that's it. How about 9? Yes, no, maybe.
No.
It's no, because 9 is 3 by 3. So the minute you think of another way to get it, it's off the list. But 11 times 1 is good. And so I'm only going to the next odd number. 13 is good. 13 times 1, that's it. 15 is no good, because 15 is 3 by 5. So forget 15, throw it into the other category. But 17 is good. 17 times 1, good. How about 19?
Good.
Good. So 17, 19, let's see if my thing got stuck as usual. The list of prime numbers goes out forever. It seems like it. So I turned this into a set of numbers. These are like a bunch of odd, strange numbers. These are critical, important. These are critically important. And the reason is that every number is either prime or it's made up of primes. So these numbers are the building blocks. Now, for some strange reason, for a while, they didn't teach prime numbers. They thought, oh my goodness, prime numbers, oh, so hard. We don't want students to have to worry about that. Well, doggone, prime numbers were the key to fractions. So if you ever had trouble with fractions, it could be because of this. These are critical. And so I think some people kind of saw it. In other words, when they saw 15, they thought 3 times 5 and they were good to go, but others didn't. And so we're pointing this out. And so here's what I want to do. This is a list of primes, and I'm going to put it on a separate piece of paper. And you don't need that many. You just need a few. And so once you have a few prime numbers, one of the things they're going to do is they're going to say, well, can you figure out if a number's prime or not? And if it's not prime, if it's composite, then can you write down the factors? So the simplest one, the one that we just did, is this one's pretty obvious. So 15 is 3 times 5. It's made up of those 2 primes. That's it. Each number is prime or made up of primes. So I'm going to go with a number that's not just too obvious. I'm going to go with the number 18. The book or the reading, the ebook, shows a couple of ways to do this. One way is it looks almost like a tree. You actually just say, oh, well, how do I multiply 2 numbers to make 18? And so it looks like this. So 18, you might just say 2 times 9. That's one way. If a number is prime, and here are our prime numbers, then we just copy it and forget it for the moment. But if it's not prime, we continue to break it down. So 9 was really 3 times 3. Notice I have a 2, a 3, and a 3. All of those are prime, and so therefore that's the answer. If you want 18, it's a 2 times a 3 times a 3. Okay, and we got it because when we broke it down, that was it. There's more than one way to do each problem. Let's do 20. So you could think of 2 by 10, but you could think of 4 by 5. It doesn't matter. Right? Now the 5 is prime, but the 4 isn't. And so the 4 needs to be broken down one more line. It's 2 by 2, and then the 5 is copied. So there's your answer. 2 times 2 times 5. That's the prime factorization, prime factors for 20. Now, let's say you do all this work and you have this terrible feeling, I made a mistake. All you have to do is multiply it out and see if it's any good. 2 times 2 is 4. 4 times 5 is 20. So this is 20. I made this up. It's kind of appropriate for Halloween. This is the skeleton version of 20. In other words, I can see into this number perfectly. I know exactly what's there. Now, how is that going to help us? Well, in some cases, one way it helps us is to reduce fractions to lowest terms. In other words, simplify it. And so sometimes you can see how to reduce this to lower terms so that it's still equal. Sometimes you can't. But let me do 20, and I just did it in the last slide. 2 times 2 times 5, right? I'm going to do 24. And so I'm going to do it on the side. Think of any way to get 24. So if the numbers are small, it's not such a big deal. I'm going to go 4 by 6. That's an easy way to get 24. Neither one of these are prime, so I break them down until I got it. So 4 would go into 2 times 2. And 6 would be broken down into 2 times 3. All of those are prime. That's what 24 looks like. So it's a 2, a 2, a 2, and a 3. When I said the skeleton version of this these two numbers, I meant it. This is exactly what's there. And so if you have to break it down, you take any match on the top and on the bottom and cancel it down to 1. So this 2 and this 2 would cancel down to 1. As long as I have matches, I keep going. I've got another pair of 2s. And when I look and see what's left, I've got a 5 here and a 2 and a 3 here. I have no matches. When I get to that point where I've taken out anything that's a match, I didn't have to figure it out. I just had to cancel 1 for 1. I multiply across. 5 times the 1 is 5. This 2 times 3 is 6. When I do it this way, and I don't always, because I could see there was a 4 in both of them, but sometimes people have messed up their fractions a lot. And this way you could, it's totally clear what you did and what it turned out to be. So you can see into this number, and when you're done, you know there's nothing left. That 5 doesn't have a match.
Can I ask how you got the 4 and the 6 and the 24 when you broke it down?
I picked up anything I could think of that made 24.
Oh, okay.
So I could have used 2 by 12. I could have used, I don't know, anything. But
Okay.
I
Could you have,
anything that's correct.
could you have used 3 by 8?
Yes. Let's
Hmm.
do it. 3 and 8. Because see, those are correct. So
Mhm.
3 is actually prime, but 8 needs to be broken down. And so I'm going to go 4 times 2 for starters.
Okay.
2 is good, but the 4 needs to be 2 by 2. And when you look how this compares to that, it's the same. 3 2s and a 3. Having them in order makes sense. And so, 2, 2, 2, and 3. Having them in order makes it easier to see it. But it's the same. So what you choose, as long as it's a true result, 3 times 8 would work. Okay. Now, this is the factor tree. And I don't know if anybody's going to go for this, but I'm going to show it to you another way. I actually like this other way, but I'll show you why in a minute. I'm going to have, here's my list of primes. I'm just going to get down a few. This is doing division. And it's actually short division because you do it kind of in your head. I start at the beginning of the list and ask myself, well, 2 divide into this number. And I believe it will because the number is even. So I'm going to divide 2 into 24, and 2 into 2 is 1, and 2 into 4 is 2. Now I say to myself, can I still use 2? And because this is even, yes, I can. So 2 into 12 goes 6. I keep going until I hit the prime at the very end. It's still even, so I'm going to go 2 into 6 is 3. Now, the minute I hit 3, I can't break it down anymore. 3 is prime. So the answer appears here, 2, 2, 2, and 3. The advantage of this approach is that you just start at the bottom of your list and work your way out. So once in a while, you're going to find a number, and I used this number before because I'm very fond of it. 51. I don't know if you recall it, but I remember numbers. 2 does not divide into 51. So I'm going to do the same thing using this method. 2 does not divide it because this is odd. So forget 2. But now I want you to look at 3. The trick about telling whether a number will be divided by 3 is to quickly add the digits. 5 and 1 is 6. It's a trick. That means that 3 divides it. Now, it's not obvious that 3 divides it, but it does. 3 into 5 goes once, and you could do this the other way for your division. There's 2 left over, and this is how I would do it. 3 into 21 is 7. So 51 is made up of 3 times 17. These are the 2 prime numbers that make up 51. And in the past, if you had to reduce a problem and one of the numbers was 51, you'd probably say done. Because 51 doesn't look like it reduces any further, but the truth of the matter is it does. There's 2 factors in 51. Okay, so this is just another approach. I didn't see it in the book, but this is another way where you just start at the bottom and you work the 2s until you're, of course it gets easier every time because your numbers keep getting smaller and smaller. And then when you ran out of 2s, you would go to 3 or 5 or 7, and so it's methodical. Okay. Now, sometimes they have larger numbers. So did anybody have an opinion about the 2 methods I showed, the factor tree, which was you had to think of what times what, or the dividing method? Anybody have an opinion about the 2, or did they seem about equal? When the numbers get higher, it may get harder to see what divides what. When I see the number 108, it's not like 20 where I could immediately say 20 is 4 times 5 and just, know it. I don't know 2 numbers that multiply 108. Do you?
Is it 54?
It is actually. Okay. So if you're able to do it, it's 2 times 54, but you had to get off the ground. The 2 is good. And so 54 is actually the answer to, if you looked at your multiplication facts, what times what is 54? Anybody know?
2 times 27.
Ah, okay. 2 times 27. Okay. Now, this is prime, this is prime. What about 27? Is that prime?
Yes.
No,
No.
3 times 9.
2 and 7 make 9, which means 3 divides it.
Yeah.
So you might say this is 3 times 9, right? 3 is prime, but 9 is not. So 9 becomes what? 3 times 3. So we have a lot of numbers here. So we have 2 2s and 3 3s. So this was possible here. What I wanted to do is show the division method, and you may or may not be comfortable with this, but it's kind of similar in a way. I start with 2 because this is even. So 2 into 10 goes 5, and 2 into 8 goes 4. See, that's that 54 we had. This is still even. So I'm going to divide it by 2. 2 into 5 is 2, carry your 1. That's now 14. 2 into 14 is 7. 27 is no longer even, so I look to the 3. 3 divides 27, and so 3 into 27 is 9. And one more shot at this. 3 goes into 9 3 times. So the answer is here. 2, 2, 3, 3. It's the same answer. So I don't know which seemed easier.
The division side, that remainder, carrying the remainder, that's true for any number that you do?
Yep.
Okay, cool.
Yeah,
And
no, it's a good one. It's short division, and at one point in time, they taught it, and they called it short division, but then
Okay.
they stopped teaching it. But I do think it's real handy, because, you know, it was not that hard to say that when you divided 2 into 5, it goes 4 times, but 1 left over, that's 14.
right,
It's doable, but if I need to work with somebody on this, that's what we'll do.
one last question, for the 27, you said 2 times 7 equals 9. Can you do that same trick for,
Okay.
or
it's-
sorry, 2 plus 7,
It's 2 plus 7.
right?
It works for every number in the world.
Okay, great.
Isn't that sweet? That means, and
Yes.
that's why I'm so fond of 51, but I'm going to do 57.
Okay,
57 is a number that you would think is prime, because whoever saw 57, right? 5 plus 7 is 12, which means 3 divides it. So I'm going to do it this way. 3 into 5 goes once with 2 left over. And so the 2 left over is here, makes it 27. 3 into 27 is 9. So 57 as primes is this. Nobody in their right mind would have thought of that. Now, you could be in your not right mind and be okay. But do you see what I'm saying?
yes, so
It
19
hides.
is,
It hides. And now we're getting into problems. You know, when they taught you in grade school, they kept the numbers small so that you could manage it. But now we're in the big league. We have to figure out how to deal with problems that are a little bit strange. And so we have to understand the rules. But 3 divides into 57. That's a fact.
and 19 is a prime number.
And it was a prime number. I don't know if
Okay.
you remember, it was on one of my lists. Actually, it would have been the next one. Because 19 times 1, that's it, right?
I see, yeah.
And so they have prime numbers that are huge, 100 digits across. But we're interested in the smaller numbers that are prime, so we can deal with things, okay? So that may or may not, let me see. Juice. So there's in this, let's see, how's our time? Okay. So what do you think? So we are definitely interested in reducing fractions and possibly using primes. Let me just do one. Now, I'm not saying that somebody might know how to do this straight off the bat and be done with it, you know, 3 minutes or a half an hour before everybody else. But what I'm saying is sometimes people have trouble with this and they always mess it up. So how are you going to manage when you you know, that was you. It never seemed to work. Now, if you can see what factors go into this, you might just immediately cancel this out. Can anybody see what goes into both of them?
6.
Let me just do this way. If we can see that 6, then I'm going to do it another, I'm going to show it with the primes as well. But if you see that 6, you literally say 36 divided by 6, 60 divided by 6. And so 36 divided by 6 is 6. 60 divided by 6 is 10. And although it's not done, it's so much smaller that I can deal with it. And so now I'm going to divide by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So that's your final answer on this. Now, I know sometimes people mess these up.
The 2 you got from just the first number in the prime numbers list. Right?
The 2, I mean,
Right.
this,
Yes, that.
I basically, when I got to this stage, I said they're both even.
Okay.
So I said 2.
Okay.
Yeah, I didn't make it anything prime, I just did that. So let's say for some crazy reason you messed it up. Once in a while, it's necessary to go into prime numbers when it's getting difficult. And frankly, even though I'm really good at this, sometimes I go into prime numbers just because the problem's annoying. And so this, you know, this might help me. So I'm going to do it the division way. I think I can get through it there quicker. So the first number is 2. And 2 into 36 goes 1, 1 left over. This is 16. And 2 into 16 is 8. So 2 into 36 is 18. As long as it's even, I'm going to use 2. 2 into 18 is 9. Oh, I can't use it anymore, can I? This is odd. But 9 we recognize as 3 by 3. There's the answer. I'm going to place it here. 2, 2, 3. Okay, that's the skeleton view of that. Now I'm going to do 60. I'm going to start with 2, and it breaks it down to 30. I'm going to use 2 again because it's even. 2 into 30 goes 15. Well, 15 is odd, but I recognize what goes into 15. And I don't really have to think because the next prime number is 3. And 3 goes into 15 5 times. So that's what 60 looks like. I'm going to write it here. 2, 2, 3, and 5. When I look at that, I've got a lot to cancel out. And so I'm going to take out a pair of 2s. I'm going to take out another pair of 2s, replacing it with 1s. I'm going to take out a pair of 3s. And what's left is the answer. And we are absolutely certain we've got it. We did get this before, didn't we? 3/5, do you remember? We got it before. And so this is just another way to guarantee that you're going to get it right. And so you don't have to use this all the time. You just might use it some of the time, although some people, they're happier with this because they're starting to get them all right. And so it might be up to you to kind of decide what's going on. What I'd like to do in the time we have left is just to start this, because this will be due on Friday, but I thought we would get a start on it. Once we've done what we've done, we've had fractions, we've made them equivalent, we've reduced them. Now what we want to do is we need to go ahead and learn 4 things. add, subtract, multiply, and divide fractions. Now, it turns out the easiest of all of them is multiply, and so they do that first. And so if I had 1/2 times 3/4, okay? What it means is the 1 and the 3 are going to end up in the numerator. And the 2 and the 4 are going to end up in the denominator, which is at the bottom. Now, I don't have to write this step, but I'm looking to see if I have any matches. And the truth is, I don't, because this is 3, this is a prime number. There's no 3s here. That's a 2. This is 4, and we're starting to look at it as 2 by 2. And so there's no possibility of a match. So I'm just going to multiply across. This is 3/8. Okay. Now, the next thing they do is multiply a fraction times a whole number. But the truth of the matter is, this format, a fraction, simple fraction times a simple fraction, is the way we want it. We want it to start like that. And so what's wrong with this one is it's not a fraction. Well, if you see a whole number, you can make it a fraction easy as pie. In fact, I left the room to do it. I mean, I left room there. So 3 became 3/1. And now I can clearly see that those two numbers are in the numerator. These two numbers are in the denominator. 3 times 5 is 15. 8 times 1 is 8. There was no possibility of reducing, because 8 is made up of a bunch of 2s. And so there's no matches. And so we ended up with this. Now, sometimes they're going to say, well, instead of 15 divided by 8, which we called earlier an improper fraction, I don't think there's anything improper about it, to be honest. They also sometimes ask you to give it a mixed number. And so let's turn this into a mixed number. This is 15 divided by 8. So 15 divided by 8 is looking like that. It goes once. 1 times 8 is 8. And when you subtract, you get 7. So this is 1. The remainder is 7 over the denominator 8. Okay. So if one of the numbers is a whole number, turn it into a fraction straight off the bat and look to see if there's anything that needs doing. Now, they may or may not ask for a mixed number. Let's see what we can do. So let's say you had that. So what you're starting to do, and the way this was taught, you'd cancel that and that, and cancel that and that. If you've learned to do it that way and you get the right answer every time, I have no problem with that. And so I'll show it to you, and then maybe we'll look at something else. But notice the 9 is on the top, the 18 is on the bottom. The reason people had trouble with this is they had to hold it in their heads. Divide by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. This is how it was generally taught. Then we'd look at the 2, which is on the bottom, and the 8, and we'd say, I'll divide by 2. 2 goes into 2 once. 2 into 8 goes 4. And then you think you're done. We could multiply across, but there's a 4 left and a 2 left. And then you would say, oh, I think I can see a 2. 2 divides into 2 once, 2 divides into 4 twice. And then in the end, and this is a mess, 1 times 2 is 2. 1 times 1 is 1. And 2 over 1 in the simplest form is 2. Some people got lost. And that's okay. And so here's, and I want to show you this other method, and then you pick the way you're going to do it. 9 is really 3 by 3. 2 is 2. 8, and 8 is a bunch of 2s, so I'm going to do it on the side. 8 is, 2 goes into 8 4 times. 2 goes into 4 twice. So 8 is really 2, 2, 2, 3 2s. 2 times 2 is 4, times 2 is 8. Now I'm going to do 18. I want to see what it looks like. 2 into 18 is 9. I can't use 2, but I can use 3. 3 into 9 is 3 times 3. So 18 is this, a 2, a 3, and a 3. The advantage of this is you can double check your work. 9, 3 by 3, 8, 3 2s, 18, I could double check that. And now we're gonna wipe out anything we can find. I see a 2 and a 2, or I could use this 2, either one, but I cancel them out and it's 1. Oh, while I'm at it, here's a 2 and here's a 2, that's fair game, top and bottom. Okay. Oh, now I see the 3s. Here's a 3 on top, a 3 on the bottom. And finally, the other one. And when you're done, you can see you have very little left. What you have is the 2. And so 2 times all those 1s is 2. And a whole string of 1s is 1. But we would call it plain ordinary 2. It's up to you which way you proceed. Now, somebody's been asking me about mixed numbers. 2 3/4 multiplied by 3 1/5. And it had to do with the area of a triangle, but I'll get to that in a second. This does not fit the form that we liked. In other words, the form that we liked was this one. Plain fraction multiplied by plain fraction. And so when you look at this mixed number, we do not have it. And so what we do is make them both plain fractions, which the book might call improper. I think they're beautiful. So we want to do this. 4 times 2 is 8 plus 3. 8 plus 3 is 11 fourths. Now that's in proper form. This one, same problem. I'm going to do the same thing. 5 times 3 is 15 plus 1 is 16 over 5. Now I've got a fighting chance. And if I look at this 11 is prime, the 5 is prime, they're not going anywhere. The 4 and the 16 is another story. I could break this, I could do one of two things. You might be able to see that 4 goes into 16 4 times. So you don't have to break it down into every little prime, but the 11 and the 5 just are not going anywhere. But this 4, this 16, we could break it down partially enough to do it. And this is another version of this canceling, the way it was taught. So in this case, even though it's not prime, I can take a 4 with a 4. Now I look at this carefully. Here's 11, here's 4, here's 5. I've got nothing that needs to be canceled anymore. And so I multiply across. 11 times 4 happens to be 44. And 1 times 5 is 5. Now, the good news about this approach is that when you're done, you know there's nothing left. There's no more canceling. It can't cancel anymore. You could make it a mixed number if that's what they wanted. And if for some reason they wanted a mixed number, and you look at the instructions and find out what they want, this is 44 divided by 5. And maybe you can do it in your head, but 5 into 44 goes 8 times. 4 left over. So this answer would be 8 and 4 over 5. Okay. Okay. Somebody somewhere in this reading is the thing about the triangle and the area. And so we've done a couple of areas already. We've done the area. Let's see, what did we do so far? No, I don't want that. My goodness. Okay. This was 5 and this was 4. We did the area of a rectangle. Area is length times width, so we multiply 5 times 4 and get 20. But the area of a triangle, they only provide 2 numbers. This bottom number is the base. And so for our example, I'm going to use 6. This number, this distance here is called the height. And in our case, it's 5 1/2. These were both in meters. So the formula goes, it's 1/2 times the base, which is the bottom, times the height. So let's take this through. So you've got a formula and you drop your numbers in from the picture. So the base, the bottom, is 6. The height is 5 1/2. Okay. So to get this final answer, we've got a little bit of a mess here and a little bit of a mess here. So here's what we're going to do. When I get to 6, which is a whole number, I'm going to put it over 1, so it's in good form. When I get to 5 1/2, it's a mixed number, and I'm going to do the same thing I just did, so it's in good form. 2 times 5 is 10, and 1 is 11 over 2. So even though I have 3 numbers to multiply, we have them all in good simple fraction, everybody's good. So now the whole question is, what do we do next? We're looking for matches, and the 2 and the 6, or this 2 and this 6, could be reduced. And so if you know how to cancel 2 into 6, just do it. If not, you might say 6 is 2 by 3. If you don't write it, you're thinking it. And then this 2 and that 2, or either 2, can cancel out. So what do I have left? What I have left on the top is this 3 and this 11. And so it's a bit of a mess, so I circled them so I could see it. 3 times 11, 33. 1, 1, 2 is 2. So if they accept that answer, you give it to them. The fact that they had a mixed number in the problem makes me wonder if they actually wanted a mixed number. but without the instructions, I can't be sure. But 33 divided by 2. So you either do it on the side or whatever. But 2 into 33, 2 into 3 is 1. 2 into 13 is 6. 1 left over, so the answer would be 16 and remainder 1 over 2. So this is the first application of this process. Whole numbers go to fractions to over 1. Mixed numbers go to improper fractions. And then you look for anything on the top that might match up with anything on the bottom. Either 2 would have been fine. I just picked this one and this one. I broke the 6 into 2 by 3. What do you say? Did that help? Somebody had trouble with that.
Yes.
Yes, so this, although some people may be all set, they can do this canceling like crazy. I'm not going to stop you. But what I want to do is make sure that every single person can get there one way or the other. Right? So I don't know where you are, but I definitely want everybody to be able to do this. And I do believe it's the prime numbers. I'm going to stop the recording. Let's see.